Also like how you filtered out Bludgeometry, which was good.
Yeah, it's kind of fun. I wonder what I was like. What? Whatever.
That was the June 6th, 2006 party over at MJ, like around Ponce.
Oh yeah.
So they had
That's
like
666.
yeah, so they had like
I remember that it was between the local Claremont
an MJQ, yeah, and also Liberty Tattoo.
Oh yeah.
Apparently they were giving out a tattoo that night.
Really?
Yeah, like some 666 tattoo design.
Something you can pump out real quick. Or...
Yeah, I don't know. I don't know what it actually did with it. I want to say it was with the glowy stuff,
Oh,
with the black
Yeah.
light stuff. I'm not sure though. Huh? Oh, it does. Oh, really?
Ooh. Weird.
All right, let's
It's
see.
one of the dark too. I don't know. Something low. I think I want to put it in. Forget about it. Yeah. Like, a little, I'm sorry? Your face is glowing.
All right, so let me move these over on the projected screen. Okay. All right, so.
Oh yeah, start.
Okay, yeah. So this is the one that created the group, and then this one discovered it. So as a join there. Now, right now it's just kludged together. It's pulling the path to the jar directly from, or to the XML file actually directly from the information in the advertisement, in the group advertisement. So obviously this is going to become something where, oh Richard, you're looking dashing today. But all right, so what it can do right now is all it's doing is getting the same XML file and then pulling it. So there's no like real messaging going on yet. And this apparently also does work over the network, at least on a local broadcast network. So we're really just gonna have to dig in and see kind of what Juxta's doing as far as how it's managing this stuff. But so the initial code for that is in paste Juxta. So what I did was I took Richard's initial implementation and then I moved it into its own package and basically just made paste Juxta just like any other application jar. So right now by default in main.
Yeah, I got more. I just didn't put it in.
Okay, we'll start merging it into the new package because you'll see that I kind of broken stuff up and then made it individual signals for the different pieces because essentially each application will be its own Juxta group, or basically network group. So these will be subgroups of the paste group, and then that kind of just each of those is kind of a sphere of influence for that application. So the idea is that each instance of the application, if you're doing one particular parameter sweep or one, whatever, not the application modules, but an actual configuration of the application with start and end ranges and all that stuff, will have a different sphere of influence. So users are welcome to join multiple groups so that the same peer could be working on multiple applications, but each application is kind of its own internal world. Um, so what you'll see here is that in main, kind of by default, what I'm doing is I'm creating just two default applications. Okay, obviously, ideally, this would be configurable outside of hard coding it. So you'd probably have some sort of initial config directory which has XML files of or whatever of the initial apps that you want to load. Okay, so in this case, the initial apps I want to load are the Paste GUI, the graphical user interface, and Paste Juxta, which is the Juxta-based network infrastructure. Okay, so what it will do is it will start those, right? And this is actually a bootstrap signal that I put in. The only reason this bootstrap signal is there is because I think we need to revamp abstract modules, and I wanted to wait until we had a little more progress on configuring the modules when they come up, like being able to initialize them without with things other than the null, other than the default constructor, because I want to be able to pass the event queue directly into the initialization. Because what I ran into with, the first time I ran into it was with this network implementation, was being able to emit signals during construction. Okay, normally you can't emit signals until you set the event queue, which in our current implementation it sets it instantiates the object and then it sets the event queue afterwards. So then there would have to be another step after that where you emit the initial, like some signal if you want. So in this case, what I did was I put the initial signal just outside of it. So the app would load up all the modules, instantiate them, and then this signal would be waiting in the queue for it. So better would be not to have this bootstrap and have it bootstrap itself and be able to just start emitting. Okay. And that was mainly for net. UI can actually load on its own. Okay. So again, this needs to be made generic. Okay. Because one of the first things that I want us to do is actually create a different user interface. I'd like a command line interface. Mainly because if you're running it on a bunch of machines, you don't want to have graphical user interfaces on all those because you won't be able to interact with them. Much less, you might not even have a graphic subsystem or anything like that. So we want something that can run kind of standalone as far as the interface goes. So I thought that was this is a neat design in that you can plug in all these different pieces. Okay. The other thing is making networks pluggable. One of the reasons I thought of that was there's the obvious reason of plugging in entire different peer-to-peer networking interfaces. Like if we wrote our own Chord implementation or something like that, you could plug that in and use that. But even more important than that, I noticed that I was thinking a little bit about how to do things like, for example, a multiprocessor box. Okay, a multiprocessor box, you can actually do parallel apps on it by just treating them as different peers, each of the processors, and letting it balance between them. Really, it's just a way of running multiple threads of the same app. So you won't be able to really, without processor affinity or something like that, you won't be able to lock them into like each processor. But the idea of running like two instances of parameter sweep where they trade work between each other would be running on, more than likely running on two, where one of them is occasionally swapping out to do network and pace event queue types of work. Okay, so you just having the ability to run multiple threads, you can just let the OS scheduler handle the rest. Okay, but and that actually works. If you create like on a single pace app, you can actually create two different like parameter sweep objects and start them both, and they'll run. And I'll watch both my cores peg as far as running them goes. Okay, but so what you'll notice between these two is that we have start and join. This one was created in the normal way of just of being in a group and then adding. Did I get something? It looks like I have some AWT exception done here. But the normal way of adding groups, and then you basically, when you add a group, you choose the XML file. For now, we're going to need to update this so that it's not configured that way. But right now, you just choose an XML file. It'll go grab the XML file, look inside it, grab the jar based on what's inside it, and then create an application thread, load it all up, and get it initialized and ready to go. Okay, and then you could start this and I don't know if any events in this AW2 are running anymore, so I'm going to kill that. This one's dead too. That one's dead too. Let me restart them. What did I throw? Let me see here. Yeah, it's something with AWT array index out of bounds. It's probably related to the tree. But let me kill this guy. Oh, this is actually, it actually is running. Dumping out work units right now. There. Then it got done. Okay. So I'm going to start another one. And notice reads new signal is throwing right there. Who wants? Because it got done, saw that the result unit was all done, and then sent out a who wants. Okay. So I'll start again. Takes a little while to get initialized, mainly due to joining the world pace group, and then joining the world juxta group, and then joining a pace group. Okay. So now you can add a group, right? So this I envision having like parameters and stuff for an app. All our application initialization stuff would be here. Essentially, it would be what you need to start an app is the modules that you want to run. Okay, we may or may not require them to list the modules within a jar. Okay, so we need to decide whether or not we want to create kind of a bootstrap object inside every jar, like an app config object that you can load initially because it'll always be in there, and then that will reference all the other modules that you're going to load. Okay, so like you could basically have one that lists worker, consolidator, input factor, and stuff like that, but it's called config, which is in every one, so all our code can reference, pull out config, look at the, ask it what modules are there, and then for each of those modules, instantiate one inside the application. Okay, so you need a jar. You need the modules that you're going to load from the jar, or some mechanism for getting at that. And then you need the bootstrap parameters, like the starting range or whatever. And then you also need what we were talking about, like a private jar that will also be loaded into the same kind of space. So we'd have some sort of parameter sweep, I don't know, admin type of jar that we could put in there. Okay, so whoever's first could put that in. That will be a jar that's not propagated to the rest. The jar itself might be propagated, but it as part of the application configuration will not be propagated. Okay, so right now I have it defaulting to just picking up that parameter sweep. It's actually hard-coded in because I was having trouble getting the dots in there. But so when I hit add group, what it will do is it'll signal, and you can watch down here for the signals. It'll signal I want a new app group. So then the Juxta infrastructure will create an app group, okay, and then it will pass that signal along to the app loader, and the app loader will then load the jar and associate it with the app group. Okay, so now we have a full application and an associated Juxta group. Okay, so if I wanted to, I could start, and it'll go through and start signaling and calculating. Okay, so let me go through again here, and if Juxta does it right, okay, it will join the correct pace group. Okay, I don't know if the problem is that it's joining a different pace group, or the problem is it's joining a different world group or whatever, because there's the world group and then pace group under that, and then each of the app groups under that. But sometimes it joins the right pace group, sometimes it doesn't. Okay, so I go out and look for it, and if it finds it, you'll see different messages come up depending. So
sometimes, like I know I ran into a couple of times where it found where before like I shut down and I restarted, and the group was still in the cache.
Yeah.
The files there, but I don't think that was actually a group. Like I think something.
No, well, see, whenever it joins something, it does cache it.
Okay.
But, like, for example, here, it's funny because it actually found the group this time. See this remote pace group found? So it actually did find it, and it did what it was supposed to. It actually found the pace group, enumerated all the subgroups of it, and it found this app. Okay? It's just sometimes it doesn't. And I don't. And what ends up happening is the code how we're doing it. You look for. You actually had a reverse, so I reversed it back. So normally what you should do is you should look for remote first. If remote's not there, you should look for local. Local being stuff in your cache, and then if you don't find it in your cache, then you should create.
Okay, so I did.
Create and publish. So you were looking local first and then remote. So it would always find local.
Oh, okay.
Well, actually, no. Actually, if you were starting off, it wouldn't find local. Then it would go to remote, and then it would create if it couldn't find any of those. So you want to do remote, local, then finally create. Okay? Because if you're local, if you find it local, that's fine because that means you couldn't find any other peers out there. So you want to create, and you've already been part of a pace group at one point or another, whether you created or you got it from somebody else. So you have it cached, so you can go to cache. And the only time you want to create a pace group is if you've never had any interaction with a pace group before, right? Because so that way, even if you go offline or whatever, the idea is that once you get enough people using pace, that pace group is de facto. I mean, it's standard at that point, because no matter how many people bow out, somebody will be up on the pace network that can keep that group kind of going. And if enough of them go away, then it doesn't matter that you're creating a new pace group. Okay, so this actually found the remote ads, and you get a little bit different here because you can see that it's now joined instead of start because it found that it's remote. Okay. Now the other thing that I have going on with these groups is that, well, actually first, how does it distinguish whether or not it's a join or start? Well, what I've added here is actually I've created a model of our application structure. So let me go on the whiteboard real quick. So, what is an app? Well, you have world pace group. So this is world. World juxta group. And then you have this idea of pace under it. Okay? And then we have apps under it. So what I've done is I created app groups. So let's say we do, parameter sweep. Okay, we'll call this parameter sweep 1. So this is just somebody wanted to do a parameter sweep, so they got the parameter sweep code, and then they set up all the configuration, and then they launched it. Okay, and that's pretty much launching a pace application is just launching it locally. And then once it's launched locally, all the pace mechanisms should make it so that it distributes itself if other peers become available. Okay, so I create a new group, and I'm a single little peer in this group. Okay, and I'm running it, and I'm part of this parameter sweep group, right? I can also both join, and then let's say we have like a clustering app. Okay, this peer, I created this one. I might be able to join this one or join that one, or actually just leave them because I don't want to be part of them. Okay, so some of these are local, some of them are remote. Okay, so let's say I'm associated with this guy right here. So each peer will maintain its view of the network as far as, for like its understanding of what the network looks like. Okay, and by network it's just groups. You're usually not even really worried about what peers are in those groups. Okay, so the model is this. Well, actually, before that, these groups are not only groupings, but they also have associated code and whatnot, right? So this one is parameter sweep jar, right? And then maybe start 0 and equals 100, and then bases, offsets, right? So that might be that app's configuration. This one might also have the same thing here, right? But start is 0, end is 1000, and different bases and different offsets. And then this one might be data file. And then queries. Oh no. data. And number centroids. Another parameter. Okay, so those are the different things that are out there. Okay, pace is just pace. It doesn't have any associated code and whatnot. Okay, so how does this look? Well, it looks like a tree. Okay, I also envision that maybe there would be subgroups under these potentially, in the future. You might be able to, one way to think about it is that we may end up, like for example, with parameter sweep. Every time you come and join, you might actually spawn groups for people that are handling those ranges, right? So that you can kind of talk within your group as far as consolidating and all that stuff. It might make it easier to find other peers that are working on your range. Okay, but we'll see how we do that. Yeah. What? You made a noise. You went, oh.
Right. I forgot.
What?
I really forgot what I was thinking.
Oh, okay. All right. Well, we'll leave it at that. If it comes up again, just go, oh. All right. So, and then this is the tree. Okay. So, what is the model? We have a network group. We have an associated application, right? And then we'll eventually have parameters and stuff inside that application, right? And then you have parents. And a parent has its children. Okay? So what I did was I created a simple... Oh, and another attribute of these things. What else do I have? The other attribute is the state of this application group. Okay? The states that I put in here are discovered, loading network group, loading application, loaded, and running. Okay? So the idea is that discovered is something that you've seen on the PACE network. Okay, so discovered means I don't have any idea what the code is, I don't have any idea on anything, I just know that there's some group out there running an app. Okay? Loading net means that I'm still creating the PACE group associated with this particular group object, right? Loading app means I'm still getting the jar, instantiating all the objects, and getting it to a state where it's ready to start emitting signals and receiving signals. Loaded means both the group and the app are done, and they're ready to start receiving signals and emitting signals and talking on the network. And then running means, I don't know if we're going to use running or not, but running will be something to the effect that the app is signaling, but loaded may imply running. Right? If it's loaded, ready to receive signals, it might be running even if it's just sitting there because it hasn't received any signals, right? So loaded and running might be the same. We might need to take that out. Okay? So that's the idea. That's what the app looks like. I mean, that's what the world looks like to PACE. Okay? So stuff like this will be parameter sweep jar. This right here, a lot of these like how the groups are handled, like the PACE juxta module interacts with that, and the GUI interacts with that. So rather than the GUI looking directly at PACE groups, looking directly at application modules and all that stuff, we're using this as the intermediary. Okay? If you remember model view controller, this is the model, and then we have all these different views and manipulators of this model coming into it so that we can make it all generic as far as and abstract as far as like this network may be a juxta network, it may be a chord network, who knows? But we don't care because no matter what peer-to-peer network you put it on, it needs to support this hierarchy of groups type of idea. Okay, so what I've done is created a model object which has, that's not my mouse. A model object which has basically, I gave them a name, a state, the children are other groups, the parent, which is a group. I don't even know if I'm correctly setting parent or not. I might not. Oh, I am. Okay.
Oh, just
Yeah.
unrelated. But when I was looking at the app queue and the network queue, it kind of looked like you were going to the parent first, and then the parent was coming back to the, like, for the
Parents
mix.
fall back as far as
but
events.
For the mix, it looked like you were doing the parent. You were sending to the parent first. I was kind of
No. I'm adding slots.
okay.
What I'm doing is anytime that I'm adding slots to an object, I need to have its event queue have that slot. But that event queue also needs all the parents above it to have those slots. Because see, an application event queue is a target for the pace event queue. So anything the application event queue can receive, the event queue knows to route it to that. Okay? But the application event queue is just an event queue. So all the objects that it has, anything that they can receive, it's it can receive those. So yeah, so on the slot adding and stuff, you'll see that. But then it's reversed it's reversed on when you actually start catching events. You actually catch locally first. If you can't handle it, you send it up. And then you eventually get to the main event queue where there's no parent to send it to, but it can go across you can go across event queues using pace. So if you have application 1, application 2, application 1 can come out, send something to application 2 via the pace event queue. Okay. I added in this app string. This will need to be more generic where we can have more information regarding the application configuration. And then some Boolean saying whether it does have an app component or a net component. Whether or not it has an app or net component. Okay? And then the current state. And then I also do this. The application object is an app. The app object is an application. It's always going to be an application. Because the application is generic already. It's already abstracted away from the other stuff, from the modules and stuff that you load. Now, we may or may not create an application, a network entity in our pace objects, but for now I just made it object. The reason being this. We only interact with the networks according to the tree structure, the groups. But networks are really only going to interact with other network objects within the same module. So we make it generic, and then Juxta internally can cast to itself. In other words, can do all its internal casting. Okay, our network stuff isn't going to cross over into others. If we end up doing that, we'll need a network entity of some sort. Okay, do you know what I mean by that? Like, in other words, if the network object in the case of pace is like a pace group. In the terms of Juxta, is a Juxta peer group. Okay, we can just toss the peer group in there as an object, and then all the other Juxta modules are aware of peer group, so they can cast it. Okay, nothing outside of the Juxta world will need to use it. Right, so that's the idea there. We may need to change that. We may need a network object. The reason I didn't do a network object right off the bat is because it worked out real nifty that all of the network implementation is actually just implemented as a regular old network object. As a regular old application object. You'll notice in main, I load it just like I did the user interface. So, ironically, the network itself, the network subsystem itself, is not a net object. It's an application object. So that represents the base, and then from there on out, you have net objects under that. So that's what the structure inside looks like. Just as an example, like GUI can go through and here you'll see I make another. What I do with this group tree model is I implemented the Java, the swing tree model interface for that tree that you see in there. I implemented that model, and all it is a wrapper for the group model from Pace. So you'll see that I can, pop in all the group items, and then this thing can navigate through the tree structure. Okay, and the reason I do that is because in the window, in the in the graphical user interface, I toss in a tree object, which a tree JTree that can go through and use the model to navigate through all our different groups. So it can maintain a view of what the current state of the groups are. So for example, all this stuff. This is just accessing the tree model, the swing tree model, which in turn is accessing all the group model underneath it. So this is just a different view, and then I just change kind of what's seen on the side and what it can do, and then the state of the buttons. I change that according to attributes of, okay, so like changing the selected value in the tree. I just go through and I ask, is it an app? Is the app loaded or discovered or whatever? And then I can set the states of different buttons and whatnot based on that. Okay, so I interact with this thing based on paste groups. So in all this stuff, the idea is that any kind of thing that you load, like the paste GUI, the paste juxta, the parameter sweep, you can reference all the paste objects you want. On the paste side, no referencing of specific objects in any of the other modules. Okay, so it all works. All this stuff signals to each other and talks to each other. Like all the GUI sends out some generic signals, like it sends out stuff like start, load, get network root, request quit, that kind of stuff. And it receives generic signals like network root, network update, load application. Load application means application done loading. Okay, which is useful because it can go check the tree. It can that's kind of a signal. Hey, check the paste tree because something's changed there. Okay. Any questions on the infrastructure? Okay, this should all run too. When you run the main paste package, but there's no explicit dependencies with any of the other packages, so you have to build them explicitly. So if you mess with paste juxta or paste GUI, just build them manually so that you'll have the jars there so that when you come back here and run. Normally, if you have related projects and you build, it'll go and build all dependent projects and everything, and you can start running. But since we're not explicitly making them dependent because we want all this pluggable, then you have to build everything manually. Okay, so this should run, and the general rule when dealing with CVS, okay, get all of your source code to a point where it can run, then check it in. Okay, if you're checking it in a way that doesn't run, you may want to tag. And I don't know if any of you have tried tagging, but oh, I can't show you because the menu bar's over here. Stupid Apple. Oh wait, I can do it on the context menu. You're about to go through and break all my beautiful GUI. Okay, so you say, well, I'm probably going to break this, so you can go in and the right-click menu showing up here too. Oh wait, this part might now it's going the other way. But you can go to CVS tag and then actually put in a tag, and that will kind of give you a checkpoint where if somebody checks out, they can actually check out at the tag, so it'll get the correct version of a bunch of different files and get that tag. Okay, so a good idea is you can tag the whole app, like all of the packages, so that they're all at one level where you know it all works. Okay. The other thing that I did that I noticed, I think you tried this too, Reed, is merging changes from if something gets changed in the back end and you've changed locally as well, so there's two different versions. Merging, what will happen is when you merge, it'll actually do everything it can where they're the same, but then there'll be parts where it's not the same. So it'll look like a diff, but you actually have to go back in and delete the parts that you have to choose. In other words, what it'll do is it'll show you here's what's from the right, here's what's from the left, and it's going to put them both in the file, and it's going to put little like equal signs to make a line between left and right, because there's the version in the repository version and your version, and then you have to go through and pick. So go through and just delete whatever. The other thing is do not be afraid to delete code. Okay, I know so you got a lot of, like, some of you are still commenting stuff out or whatever. Just delete it. Just delete it, because all the commenting that you normally do is now in the version history. So even for stuff that you might want it like in a little bit, just just delete it. And if you say, well, okay, well, I need to, my little experiment didn't work very well, so I need to at least get that little snippet of code back. So what you do is you just jump into something and then find something with some better history on it. Oh, perimeter sweep has some good history. No. Oh, consolidate. Okay, so we can go to consolidator. Anytime something, you're playing around with a different approach and it doesn't work, so then you can go over here, CVS show history or search history, and then that will bring up the history, and you can even go in and see the difference between that and your current version. And you should be able to do that in a bigger window, but I can't. I don't know how. Okay, but you should be able to go through and then just find the piece that you wanted, cut and paste it back in or whatever, or you can revert or whatever. See, so one of the things that you'll be that might happen is there's a bunch of the stuff that you added that you like, and then there's some little stuff that doesn't work. But so you can't just revert back to the repository version. So what you can do is use diff to go through and pick out the parts that you want back. Okay, so I recommend kind of getting familiar with some of these CVS features. Like for example, when I started adding in the GUI, I actually went ahead and branched. So what I did was I branched, did a bunch of changes to a lot of the kind of paste, like a lot of the stuff that wasn't related, the stuff that the GUI touched, but I know we had a working version with the text interface beforehand. So I could sit there and I could actually track changes and check stuff in without worrying about what I did to the mainline branch that you guys were looking at. So I could sit there and do changes, and then once I got the GUI working exactly how I wanted, then I can merge back in. And then when I merge back in, luckily you guys don't do any work, so most of the time my branch can go through the whole branch and then there's nothing different from mainline. But what I can do is I can look at the delta between my branch and mainline currently, because mine was built off a different route, right? So if you guys started modifying like something else along the main branch or along the root branch, my changes that I made didn't track yours. So I'll have a delta between the current new head and mine, so that I can go through and pick out, well, surprise, they actually did some good, implementation here. I'll keep that, and then, on my end, I'll go and pull in my stuff that I needed changed in order to implement the GUI. Okay? So if you're going to be doing some big revamps, branch. Okay? If you're going to be sitting there with a bunch of checked out code for a while and you still want to use CVS so that you can check your stuff in, so you can keep moving along and reverting, trying something and breaking and coming back and stuff like that. So you can kind of do your own little branch, work on it a little while. Just keep in mind that when you're working on a branch, stuff's going on along the main line. So every once in a while, check the main line. You might want to also do periodic merges where you can merge the main line to your branch as opposed to the other way. That way you're closer when you finally actually do merge back into the main line. Okay? So this is a useful skill, period. All right, being able to work with CVS and version control is a useful skill, period, because if you get into any situations where it's more than one programmer, version control is critical, because you can not only roll back mistakes and stuff like that, but then they can also audit changes to make sure, like, if the application which is close to its deadline completely breaks, they know who to blame, because their login says I broke everything, right? So keep that in mind when you're coding out there. Okay.
I did that over the summer.
What's that? Oh, broke a bunch of code.
Yeah. This guy, the outside developer, he just was like, just FTP. I was like, okay. And I usually remember to copy and make like a
backup
right next to it. One time I was like, this guy's lazy. He's not doing this, so I'll just implement it myself. And I didn't like grab the new one and put it in. He's like, dude, you just wiped out
The whole
like,
site. Like,
yeah.
the whole site's broken because that file touched everything.
Yeah.
Yeah. So this stops that,
Yeah.
right? Because anything that we see, Nick's login on, we can just roll back and know that it's probably broken. Right? So keep that in mind. Now, Juxta. I've broken it into 3 different modules. Down here. Okay. So I got Discover, Juxta Launcher, and Paste Peer Group. Now, when I was playing around with the network stuff, I ran into a few things that we're going to need to decide whether what we want to do with it. One is I initially started implementing the idea of a idle event. We may or may not want to do an idle event. I think that the network and the apps and stuff are event driven enough that we won't need an idle event to kind of jog things. The reason I put in an idle event was to periodically run this discover to discover new things on the Pace network. Ideally, we shouldn't use it. We shouldn't need it. In other words, we shouldn't need to poll the peer-to-peer network. We should be able to poll once when we start up, and from there on out, we should be able to receive Juxta events saying a new group was created and it's been published somewhere that you can see. And then everything else would be explicit searching. But let me walk you through how the network starts. So, the first signal that comes in actually comes from outside. Again, this is going to be true until I can emit signals in a constructor. Okay, once I can emit signals in a constructor, we don't need to do this. But I bootstrap with start network. Okay, so where does start network come in? Actually, we have a nifty little diagnostic message that can tell us this. Start. There it is. Okay. So start network. Right here. Okay. Juxta launcher gets start network. Okay. So Juxta launcher. Here we go. So what does start network call? Calls network root. Oh, by the way, start Juxta actually runs by being called by the constructor. Right here. Better would be, well, actually, that's why the initial signal is start network, because normally, if I could emit start network here, then this next part would happen. Okay, so the next part is discover is network root. Okay, so network root here says, this can be cleaned up. This is one level of indirection that might not be necessary, but anyway, notice it says if this dot pace group, if pace group is null, pace group is a pace peer group, which is this object, right? If I don't have one of those started up, I'm going to need one. So what I do is I say, see, the thing is there is a pace peer group out there. I don't have access to it. Why? Because pace loaded it from a jar outside of me. Right? Normally we just pass this parameter into this and be able to use that pace network object, but we're not doing that, right? We're signaling. So what I want to do is I want to get the pace peer group object from the pace peer group object. I'm just going to say, which of you is the pace peer group object? So I say query pace peer group, and I send it, I send it the net peer group. So the net peer group, right, is a Juxta peer group. Okay? The Juxta peer group was started here. So this is the generic world start of Juxta. All of the example code uses this, and funny enough, this is a deprecated interface that you should be using something else, but there's no example code anywhere on the net which says how to do this without using this old interface. So, who cares, all right? Juxta's silly, all right? So, we start up the world peer group, and I pass this world peer group in my query paste message. So, query paste goes to whom? Well, query paste was received by paste peer group. So, let's take a look. Paste peer group will receive query paste. What will it call? Report paste. Report paste is here. So report paste will say, well, this is, first of all, thanks for the net peer group. So I know who the world peer group is now, which is good. Right? I'm going to need that so that I can create peer groups inside the world. All right? And in return, I will emit report paste, holding a paste peer group object. That should actually be capitalized, but and I'm sending myself a reference to myself in this signal. Okay, so who do you think receives report paste? The Juxta launcher, right? Gets report paste. So let's go to Juxta launcher. Report paste will call discover paste. So discover paste. Here's where we start getting into the Juxta code. First of all, I set the paste group, right? That's what I asked for. I said, hey, who's the paste peer group? It returned to me, I'm the paste peer group. So I do my casting as usual to grab that data out of the signal. Okay? I create a discovery service and an empty discovery variable and a peer group advertisement variable. So what do? First, I query, I get the discovery service for the world peer group. I get that discovery, and I add a listener. Notice what I add as the listener. This.peer group, which is this object. Right? I add that as a listener. This is the Juxta event interface. This is the Juxta event infrastructure that I'm adding this for. Okay? So I add that in. Then I trigger the querying for remote advertisements. So what I do is I say, give me the groups out there in the world group. Okay? And then I wait. Okay? I wait. This might not be the place to put this. Okay?
Don't you do it that way?
What's that?
Yeah, you do it that way. You don't have to wait.
Do it what way? No, I have to wait, but this is why. I have to wait because when I remotely query, what I'm going to do after that is create a group if I can't find it. So I have to give it some time to look for the group. But see, what I've done here is I said this wait because things can actually happen outside of this. Because we're in the thread, we're in the application thread that represents the Juxta infrastructure. I mean the Juxta, the paste Juxta. Okay, paste Juxta was loaded into its own application thread. The thing is Juxta has its own threads. So this, the response from this can actually be triggered even though our main application thread is paused. Okay? So here's what I do is I actually wait for this long and then I remove the listener. So within that time period of me waiting, that other code should run if there is a remote, if there's a remote advertisement. And then what I do is I say, discover paste is done running, so I emit discover paste, and I pass this net peer group. I actually don't need to do that because it's already handled, but I decided to pass it anyway. So where does that go? That's discover paste. Notice what happened in between discover pace and report pace. Notice stuff happened, which is juxta threads manipulating those objects behind the scenes. But what I do here is I say, okay, so discover pace happens, right? And it's received by this object. Here's where multi-threading is going on now, so it's going to be confusing, okay? Discover pace goes directly to where? Create pace, right? So let's go down to create pace. Here's create pace. But behind the scenes, another event model, another event infrastructure is happening. And that's the juxta event infrastructure. So the callback that was, the listener that was added here, which is this pace group, which is this object, actually calls a well-known interface called discovery event, I believe. Yeah, discovery event. So this method can happen during the wait. Okay? So either this will run or not, this will run or not run. Okay? But eventually the other one will run. So let's look at the two scenarios. Let's say this does run. If this does run, I receive the juxta event, I parse out the advertisements, and I enumerate through the advertisements that come back as an enumeration. I enumerate through all the advertisements that were found, and I look for, I'm actually just grabbing anything out there. I should be checking if this is the pace group. Okay? So what I do is I find a pace group, and I'm printing out here a remote pace group found, joining, and then notice what I do here. I synchronize on what? This dot pace group. This dot pace group is, actually I can do it on my nifty little IDE. This is within here, fields. By the way, I really like NetBeans these days. I've been using all the different features, like all the little conveniences, like wrapping with try-catch, fixing imports and all that stuff. They actually did a pretty good job with this deal. Pace group. So I'm syncing on pace group, which is a group, a pace dot group, right? A group in the pace infrastructure. Okay? So, what do? I sync on that. Pace group represents the root of the pace network. There was the world group, and then there's the pace group. This is the pace group. Okay? So what I do is I sync on that. I check if its net object is null. If its net object is null, that means that it has not been initialized. Okay? Why am I syncing on this? Right. I need everything between this bracket and this bracket, these two braces. I need that all to happen atomically, which means all of this needs to happen without any changes to this dot pace group. Because these steps that I'm taking are dependent on that being null. If I check it's null and I start doing this stuff, but the other thread sets it to something, I'll clobber it. Okay? So what this is ensuring is that pace group is modified by only one thread. Okay, this is known as a critical section. So what I do is I check if it's null. If it is null, I go through the machinations of joining the discovered pace group, and then I set up my model object appropriately. Okay, I set its state to loaded because this is the world pace group. If I join the group, I'm done. Right, everything that has to be doing with that pace group is done. I set its net object to this pace group so that other objects can get at this network object. There's no app information. I set the name to the group name, and then I just print this out for diagnostic. And then I also go ahead and update that the discovery. I go ahead and grab the discovery service for the pace group. The discovery service is a separate service that can go through and query a group. So I get the discovery service for this group, for pace. And I set this pace DS to that, just so I can hold on to it. And then what I do is after that, I signal. So this network root is this. Network root. Network root. Oh, it's on screen. All that is checking if it's null and then emitting. It emits init and network root. Okay, network root is mainly for the GUI to let the GUI know that something has happened with the paste network. Init is for other juxta objects. Is everybody cool with that? That's setting up the initial paste group. Now, what was the other option? The other option was this doesn't run in time. Okay, so we time out on the wait, and then we actually go to create paste. Notice that I'm syncing on the same thing. This dot paste group. What do? Check if it's null. If it's null, that means that nothing is modified paste group to get the network. So now what do I need to do? I need to do a local one because I couldn't find it remotely. So after remote comes what? Local. So what I do is I check the local advertisements. Local advertisements are basically stuff that you've cached. Okay? So I check the local advertisements, I enumerate through them, and I try and find the paste group and I join it. Okay? And then I also publish it on the net peer groups discovery service. That's so that other things can find my paste group that I just created, which doesn't apparently always work. If I cannot find one locally, in other words, this enumeration, when I check the local advertisement, that enumeration is empty, then what does that mean? No paste group has ever been created. I create one. So what I do is I create it. So in all of these, the final result should be PG should be set to the new or locally cached paste group. I set the name, I set the net object to this paste group, and I make sure it's not null, and then I grab the discovery service, like I did with the last one, and then I set the state to loaded, and then I emit. And then I'm done with my synchronization. Okay? So, either this, that one we just saw, or this will emit these two signals. Got it? So by the end of all that, we should have a valid paste group in the world group, and we should emit these two signals. And we also have a group object set up with this valid paste group. So init and init and the other one is not being printed out. The other one is for the GUI. So let's look at init. It's received by discoverer. So discoverer gets init and runs init. What does it do? It gets the data, which is the group object that we just created. Okay? So we take the group object, we hold on to that because we're going to need it later. So we hold on to that in the paste group member. Okay? Then what do? We get the net object off that group object. Okay? The net object off that group object is a juxta peer group. Right? The group object that we saw was a paste group, which is our generic model. This peer group object is specific to juxta. If that's not null, we grab the discovery service. We add a discovery listener. What discovery listener? Us, the same object. And then I flag that we're ready to start discovering. Okay? And then what do? I just go ahead and call this once. Discover will make sure that we're started, right, from this flag, and that we have a discovery service. Okay, we shouldn't really have to check this paste discovery service because if the only way we can get to start is if that discovery service was set. But I was checking just in case. Then what we do is we say we're getting the remote ads. We get the remote advertisements and then we just let it run and then just be done. Okay, why? Because in the Juxta infrastructure, it will call back this discovery event listener. What will it do when it gets it? It'll get the response. It will make an enumeration of all the advertisements it found. It'll print out a little nifty little message, and then it will merge the groups. What's the merge the groups? Merging groups is it goes through all the advertisements and checks them against all the advertisements that we already know. Where does it store the advertisements we already know? Any guesses? If I've been out there, I've gotten all these advertisements for different services. Where do you think I should store that? All those advertisements represent groups in the network. Yeah, like even the local, but we also could have discovered stuff off the network too. But how do I keep track of what I've discovered and what I haven't discovered?
Cache.
Well, it's in the cache for Juxta, but where do I store it in the app, in Pace? Where do we store data in our application? Where are we keeping track of stuff? No. In the model. Okay? We need to enumerate through the model, see what groups we already know about from the model. Okay? What we do is we look at the groups that we've seen from these we check what the advertisements say. And then what we do is we enumerate through our model and say, are there any advertisements in here that we don't have in our model? If we find advertisements that are not in our model, what do? Add them to our model, right? So now we have a consistent view of what the entire Pace network looks like. So we iterate through, we check to make sure that if we ever find the Pace, we check each one of these, okay? Yeah. First, I enumerate all the children under the Pace group because that's the discovery service we're querying is the Pace group's discovery service. What do? I get all the children and I keep them in this this linked list, okay? And then what I do is I check to see if this linked list contains the new advertisement I just found. If it does not, I say I found a new Pace group, I create a new object from the model, and then I add it as a child, and I emit that this new group that I added is updated. Actually, you know what? This should be group. Which will end up being the same thing, but once we get into more stuff. So what I'm telling the rest of the application is this particular node has changed. Who would be interested in that node changing? GUI, right? So the GUI can catch this and say, oh, this node's changed. I'll go through the tree. I'll find out where that node is, and I'll update it. Update the display. Okay? So what have we gotten to? We've gotten to starting up Juxta, having the world group, finding or creating the Pace group, and we have our model consistently showing all the subgroups of the Pace group. So what would we want to do next? We'd want to create an application. So how do we do that? We do it in the GUI. In the GUI, there's a nifty little button that's add group. In that add group, we give it a file name, which is the XML file, and a name for the group. This will need a lot more stuff, but for now it's just the XML file and then a group name. The button for adding that is called new group action performed, or new group. So, once we receive that event, what do? Well, we start off by creating something in our pace model that's going to represent this new application. This application represents both the code that's running and the network group associated with it. So what do? I create a new group. I set its name based on the text input that the user gave me. I set the app string to the XML file for now. Again, this will need to be a complete object that describes the application eventually. I set the flag that it's an app to true, and I set the flag that it's a network to true, because each application is both an application and both a network. Okay, we've seen all three combinations too. Okay, something that's a network and not an app is the pace group, is the main pace group. Something that's an app and not a network is the GUI and the Juxta module. Both of those are applications but not networks. Okay. Applications that we load from jars are both apps and nets, and there's none that's neither. There's no case of it not being an app nor a net. Okay, so I create the initial node, and then what I also do is I add this as a child of its parent. In most cases, this will be the initial. It will be the pace group, the root pace group. Okay, we'll eventually want to make it so that pace groups or application groups can have subgroups or whatever, like any arbitrary structure we want. But for now, what we do is we select the last selected component, which is whatever was highlighted, and usually that's just going to be the pace group, and then we add a child. Add the child in. Okay, and then we admit that we need a new app group, and this is the associated group object. Okay, so new app group ends up getting routed to the network subsystem. It'll actually be routed to pace peer group. New app group will call create application group. Okay, create application group. We grab the group that was sent to us, right? We initialize peer group, and then what we do is we grab the, what are we doing here? Pace group. Oh, we grab the Juxta peer group that represents the root pace group. Okay. This is actually incorrect. We should actually be grabbing the parents. We should actually be grabbing the parent of this. We should be grabbing group dot get parent, which is also a group object, which will have a getNet object under it. Okay. So we should be grabbing that, and that will be a peer group. Okay? When we grab that, we can then use that group to publish a new group. So what we do is we grab from Juxta, we grab this generic advertisement, and then we pop in our name and a little description. In this case, I'm using the app string as the description. That'll need to be something better. Okay, it'll probably end up being like a reference to a file that we published on the Pace network. Okay. So we get a new group, right? and this new group is stored in PG. What this is saying is, in the group that is the parent, because that's already established, publish a new group under it, and name it this application from this application object. Okay, and then what we do is we grab the discovery service of that paste group, and then we publish the advertisement. Okay, this should also be group paste group get discovery service. All right, and then we publish it, and we publish the group. Then what do? We set the net object of this group to the newly formed peer group. Okay, I'm changing the state, letting it know that the network's done. Now I need to load the app. And then what do? I emit load, and I pass the group object along. Notice this is taking the group object that we initially created in the GUI and then passing it along through the places it needs to go. So we pass it to the network first, right? Who's next? Application's next. So I go into a new object that I've created in Paste, which is application launcher. Okay? So it gets load, and we'll call load application. So what is that? Well, load application, we'll make sure that we have a valid object, and then it will grab the group object out of the data. Okay? It'll make sure the state is set to loading app. And what it will do is it will create a new application object. An application object is a full thread of execution with its own event queue. So what do? We create a new application object, set its parent event queue to the main Paste event queue, right? Grab our nifty little sax loader, which needs to change. We're going to need to get that. It's a little too dependent on static like static variables and stuff, and we need it to really spit out. I think we need to have it spit out like a config object of some sort.
Yeah, that like orientation module.
Yeah, and I think it'll need to be.
That's what contained.
It needs to spit out the thing that's going to have like all the initial parameters and stuff.
Yeah, that was it had the app parameters, the jar path, the admin jar path, and peer group.
Right, and then also the private jar as well, right?
Yeah, the admin jar.
Okay. So we'll need to get all that stuff out of there. Now, whether or not we sax load it somewhere, whether or not we XML parse it somewhere else, or we do it here, I think we'll need to do it somewhere else. The reason being is that apps can get loaded without any XML. So what I'm thinking is that we'll actually send it somewhere else to get parsed and turned into this orientation object, and then all we get is the orientation object. Okay, but we get this. We get the config information, and then this is the same. What we do is we create all the objects based on what was in there, and then once we instantiate the object, we pass it into the app as a new object for that application. Okay, so we pass that in. We loop through all the classes. Once they're all started, we're done. Here I'm just printing out some debug information because when you start getting into all these dynamically loaded things and multiple threads, the debugger gets way confused. So sometimes you have to just drop down to old school printing out debug messages. But eventually we can get rid of some of this stuff. But this is just printing out the slots that were there. Okay. Once we create this app just loaded up all the modules, instantiated them, and they're all ready to go, start sending signals and whatnot. So what do? I update the group object. I set its application object to this current app, right? I add this to the list of apps that this application launcher is tracking. Okay? And then I set the state to loaded. Because I'm done loading the app, I'm done loading the network. So now we're loaded. I start up the app, the app's thread of execution, and then I emit load application. In other words, application is done. Loading. Where does that go? That goes back to main window. I believe, yeah. Load application, tree update. That's just saying refresh the tree, let it know that this application's all running. Okay? So now we have the app running. What we would want to do next, we'd want to run it. So that is done. Once this thing is loaded, you'll notice that the tree selection update can check if something is an app, and it will set the start button set to the state equaling loaded. So now that this application is loaded, the start button is now available. The start button will, when we push the start button, we'll grab the node that's selected. We will pull its app object off, and we'll enqueue a new event saying start. So this is direct signaling to that queue. It's not going through the pace event queue. We directly signal the app object's queue. This is so that a start message doesn't go affecting other apps that are running. Okay? So these event queues in this event queue hierarchy is a way of limiting the scope of your different signals. Once we get a start signal, well, you guys know what goes on there, right? It starts getting into our parameter sweep infrastructure. And then all that stuff's handled locally. The only thing that goes out are stuff that's not handled by the objects themselves. Does everyone understand this? Yes? Okay. Stating yes means that you can write code for this. Everyone understand where all these signals are going? The sequence of events that happen, where we're trying to maintain abstraction, where we can get specific about objects and things like that?
Yes.
All right. Has everybody run this?
No.
No? Okay. Everybody make sure you pull down all the most recent packages, compile all the separate pieces, run it. Okay? You should be able to run all the way to running an app. Okay, where you run the parameter sweep and get the final printout. Okay? The major things we need to do now. I want a text-based interface. I want a configuration system for the PACE application to say what initial modules to load. In this case, I'm loading the GUI and the Juxta. By default, I want that to happen on its own. I mean, by a configuration file. That way main is untouched. Right? I want those two things. I want... What else do I want? I'm not going to try writing other network interfaces yet. Those are two big things as far as, kind of just really infrastructure things. Now, the other thing we need to do is get signaling, remote signaling done. Everything outside of that works. Okay. Obviously, we need to update the GUI as well. Okay. We need to shore up this. What do we want to initially pass into the application? So you're working on like an object, right? That holds this stuff. What do you have for that object? And if this were checked into CVS, this discussion would be a lot simpler because we could just pull the code up.
Okay.
But what do you have in there right now?
Right now it's serializable.
That's another thing. Checkpointing and pausing and quitting infrastructure. That's going to come next. Go ahead.
I have the path to the default jar, the one that everyone will get. I have, which is a string.
Okay, so you have a path to the public jar.
Yeah. Peer group name.
Okay.
I have a list for app parameters.
App parameter So that's just a generic list. Do I
Just a
specify
list.
type?
Let's see. Right now, yeah, I just have generic list
Ah.
just for objects.
App parameters.
And then I have a path to the admin jar.
Private jar.
Yeah. And I was thinking I was just gonna make that private jar transient. And that way, if we're gonna send this to other nodes on the network,
Oh, use serialization.
use
to trigger it.
serialization, and they would never get that admin jar.
What about when the application quits and restarts? Peer 0 will still need it. Okay. The hardest part is going to be how we're going to do these parameters.
Yeah, just for
I mean, we could just make them single things. I mean, like, because for parameter sweep, there's X, there's Y. I mean, there's start, there's N, and then there's a list of offsets and a list of
bases.
bases. Just load it in order. I mean, I guess we could just. I mean, we can make them specific to like an XML file could be specific to a program. So how should we store them in the object? There should be an object for the program. I mean, in this one, there should be an object and parameters, and that parameters can. We want the parameter object to be specific to the app. This object will be paste generic. Do we want a parameters object that's application specific? Because there's two different approaches, right? You can create a parameters object which is like, you know, like a parameter sweep. You can make like a parameter sweep config like a parameter sweep config which has stuff like a Y or that has start and bases, offsets, right, which are lists. These are ints, right? So you can make this object, right, and then which can be some subclass of some generic, config object, and then just attach it here. Okay, so this will remain case. This will be parameter sweep. Right, because we can actually go in the jar, grab an object like this out, and then initialize it using an XML file if we want it. Or a serialized object or whatever. Or you can make it paste generic, where it's just a dictionary, start, end, base 1,
Just name type.
base 2, right? Here's the difference between these two. This one, when you pass this config object into something like input factory has to parse this. In this one, by the way, this is a dictionary object, right? This is a map. This is a hash of keys and values. So this would be a generic, map object here. But then in input factory, you need to go through and say, look up value to start, make sure it's an int, grab it, end, int, grab it, base 1, grab it, grab it, grab it, grab it. build an array, build a list or whatever of the bases, build a list of offsets, put that all together, then you can give it to different places that need it. Initialize your result units with it, or your work units with it, and all that stuff, and you package it all up. Okay, here it's already in this form. You can actually just go in and grab start, grab end, grab whatever, just copy it. I'd rather do this. Why would I rather do this? Because it makes programs easier to write. Right? This makes paste easier to write. We only have to write paste once. We write this a bunch of times. Okay? So, the thing is, so now we have this custom object that we pop into the jar to get the app ready and configured. Well, if we need to put this custom object in there, we might as well create a custom object that enumerates all of the modules and stuff too, right? So there needs to be some sort of thing in the jar that can kind of get you ready, right? The application loader, the application launcher can go to the jar, grab this object, and then some other ingredient. So it grabs this initial object, and it either also grabs an XML file, or it grabs something that was, or this orientation object, this like kind of configuration object, came from one of two places. It either came from the network, or it came from, or you created it, right, from like an XML file or something. So peer 0 loads up, grabs an XML file, initializes this object, and pops it in. Or maybe not from an XML file. It created it by going through a GUI and clicking a bunch of stuff. And then it created this object, right, that we can pass in. Okay? If you're coming from the network, you got this object from an input factory, or something that orients other objects. Okay? So, one thing that it needs to do is give us a, so this kind of, this bootstrapping class, this bootstrap class needs to do something along the lines of enumerate loaded modules or loadable objects, or let's call them base objects. These are the things that an application launcher would instantiate. We saw this loop that I went through where I'll instantiate a worker, I'll instantiate a consolidator, I'll instantiate an input factory. Done. On the GUI, I'll instantiate a main window. Done. On the Jext, I'll enumerate I'll instantiate a discoverer, a paste peer group, a Juxta launcher. Done. Okay. So we have this enumerate base objects. So that's for This is used by application launcher. Generate a config object. That's this. Okay? This generate config object is generate a config object from XML. Because we don't need to generate a config object using this.
You're only going to have to generate it if you're node 0. Otherwise, it will be given.
Right. Everybody else can actually instantiate a config object directly, like in input factory or something like that. Yeah. Okay. So we need to generate the config object. Do we want to say from XML?
Or from the GUI.
Because we might do it from the GUI as well.
It would be easier.
From structured data. From this. From a dictionary. Right? So we take this work and put it into the loader object. And we put it into the base class of the loader object. Because there'll be a... Ooh, we don't Actually, bootstrap object, we will. Oh, we're going in circles here because if you have a generic bootstrap object that can generate all this. No. Okay, no. It's application specific. You subclass off of the paste bootstrap object. You subclass off it, create something like a parameter sweep bootstrap object. That's the initial thing you load. But it will be specific. It will have its own code in there, but there'll be superclass methods like parsing a dictionary, stuff like that, so that we can just pass in maps. Okay. Generate config object from map. From map. If we're generating from XML, we'll just send it through a little thing beforehand that turns it into a map, and then we'll pass the map in.
Alright, so I'll change sax loader to generate a map.
Yeah.
And then
We'll generate a map. But this kind of mapper from a map to a config object, this will be application-specific code inside this bootstrap object. Okay. What else does this thing need to do? That's it. Enumerate modules, config object. We should store a pace, a network ID of some sort, a name. A name.
sweet.
The name, though, is for the jar. Right? It's for the code, not for your instance of the code. A name preferred private jar. So that if you're running parameter sweep, your generic kind of private jar that you load to make sure you're pure zero will be this preferred private jar. But this can be overridden by the user. Like if they have a fancy jar that does a graphical output at the end, or it pushes the button to blow everything up or something, whatever it does, it can do something different. So the preferred private jar, and that's it. Right?
Okay, so just to make sure I better, we're gonna have this bootstrap objects, all that, and that config the config object within the bootstrap is gonna be
Anything you want. Anything the application writer wants. You don't write that.
alright.
You write that for parameter sweep.
Okay, so all this stuff that I had earlier, the path of the jar, peer group name, all that's just getting moved to this bootstrap.
And it returns a config object. So this parameter sweep config object is just this. It's simple.
Yeah.
Right, with these members. It doesn't even need to be subclassed off of anything. It can just be an object. It's a regular object because we'll just cast it within, like initializing these different modules. Okay. How do we generate this object? We generate this object like in the GUI right now. The GUI has an XML file entry. Okay? So, and a name for our instance of the app. So, we should be able to take that name, an XML file. The XML file will then be parsed, and in the XML file we'll find the initial jar. We'll find the initial jar and a map. Okay, so we find the initial jar and a map. That paste should then go get the jar, open the jar, instantiate the bootstrap object, and then instantiate the bootstrap object, feed in the map, and get a config object out of it. It should get a config object, an enumeration of base objects, a name, and it should check the XML file if there's a different private jar or not. Otherwise, it should default to the bootstraps jar object. See, what I'm thinking is this is all going to get passed to application, to the app launcher. An application launcher looks like this. Looks like this right now. All this goes away. All this goes away. And it becomes, this even goes away. This goes away. This goes away. We can do it in App Launcher. Yeah, let's just do it in App Launcher. Just give it an XML file, just like it's doing now. Just leave it here.
Okay, so yeah, just change the XML.
Change all this to that. Change all this to that. Yeah. The XML file will change. The XML file will just be the jar, the rest optionally a private jar. This parser then becomes first getting the parameter, first getting the jar, and then we quickly go ahead and, once we get that jar, we quickly go ahead and instantiate it. First of all, enumerate the loadable modules, because that's what we're going to do in this loop, so we can enumerate them. Which is just, you can just make it a list of text strings for now. A list of text strings being basically everything that you see here. Instead of getting it from the XML file, we'll get it from an object. So these will go away, right? But we can't start instantiating them the objects yet, because we need the config object to pass to them for instantiation. So I'll just write it in here. All right, so we parsed XML, right? Boom, done parsing XML. The next thing we do, so now XML parsed, what do we have? We have a list of modules, right? We have a config object. No. XML parsed.
Yeah, we just have a
No, we have a path. We have a jar path and a list of parameters. A map. A map of parameters. Okay? So, what do we do next? We
create the config object off that map.
No, we open the jar, get bootstrap object. This is with a generic name. In other words, anybody who creates a PACE application will name their bootstrap object bootstrap or whatever. Okay? So we open the jar, instantiate whatever object in there is named bootstrap. No initialization parameters. Right? So, so we get a bootstrap object. Ask bootstrap object for list of modules. Right? Ask give bootstrap object map and get config object. Is there anything else we extract from the bootstrap object? The preferred private jar and the name. Okay, so we have a jar and a map of parameters. Optionally preferred private jar. Okay. If we got a preferred private jar, actually we don't need that yet. We do that. Do the same for the private jar if available. Because there's sometimes when you don't even use a private jar at all, and that's when it's on another box. Okay, so we do the same for the private jar. Okay, so now what do we have? Now we have a list of modules and a config object, right? Okay, so we're done with the bootstrap object. Now what do? We iterate through modules, instantiate using event queue and config object. And we're done. And we're done. We're done. And we're done. We're done. We're done. Are we done? Are we done? I think we're done because a new peer, you're a peer. You go and you find all the discovered applications out there. You say, hey, I like that application. I'm going to join it. You join it, and it gives you a jar. It gives you the public jar. You download the public jar. You create an application with the public jar using no parameters. Yeah, giddy up. No parameters, an empty config. Because you'll start signaling at that point. Right? Once you start signaling, you'll start getting work from other things. So input factory needs to be able to generate, actually it doesn't even need to generate a config object anymore. Because these things will be loaded empty and it'll just sit there, right? And except for signaling. It'll create empty ones, and then those empty objects will then start signaling because they're empty. So they'll do stuff like, I don't have any work. I've initialized input factory to 0, 0. I got no offsets. I got nothing. So what will I do? I'll signal orient. So an application should be able to start just with the initial jar. Right? No config information because it'll just ask the bootstrapper for what? The list of modules. And it'll instantiate the list of modules. And then the signaling will happen from there. We still have no remote signaling. We need remote signaling. We have something close because boxes are talking to each other.
Could you make
We need these pipes and stuff up and running.
And then, so if you want to, like the way we send signals, is it?
Well, we're just going to broadcast it. I need a mechanism that I can say, send this message or receive this message. The other mechanism I need is a generic way of storing files on the network. Okay? I need to be able to say, give me this jar by name. I need to be able to say who has this jar and transfer it to myself. Because the idea is this, you have some sort of local cache inside here that is just, I mean, you have your paste, your paste files in here, which just has jar after jar after jar. Okay, jar after jar after jar. Okay? Because those things are all you need to join applications. You join an application and it'll say, oh, I'm using this jar. And then you'll go through your directory and say, oh, I don't have that jar. I'll ask the network. I'll get the jar. I'll make a copy here. And then that's it. From there on out, when I go to the application to start it up or whatever, I have the jar. And I can reference what name of the jar because of this stuff. Right? Because I've been told what the name of the jar is. That's the only thing that is really sent in an application group is the name of the jar. Because what config information we'll get is handled by the scope of the group. In other words, you'll only be talking to other things that have the parameters you need. Right? We don't need to pass XML around. Right? So basically, if you give me the jar, I should be able to load the jar, and that jar can start talking. That jar can start signaling stuff and saying, hey, I need work. And the only people you'll talk to are handled by the group scope. We have that mechanism already in. So we need a way that we can have jars sitting in a directory, and if a jar is not found, we should be able to get that jar into the directory. I need a way to transfer files. I need it now. Okay? I need a way to just transfer a file. Nothing fancy, just here's a file, send it, I'll store it in your directory. Okay? We need to start thinking about persistence. Okay? This is like a paste library. This library is across all groups. This is a global library. Okay, this might be a well-known group. We just might make a well-known group that has these files. We might even make it a well-known group that is outside of the paste group. I don't know. No, we'll just make it a subgroup of the paste group. The only reason I say make it outside the paste group is because it's there whether we have apps or not. In other words, I would say make it outside the. I'm going to make it outside the paste group. It's going to be outside the paste group because on your little tree, paste will have all the applications listed, and then you have this little thing outside which has just for transferring files, right? And then those files are in a directory. Well, if they're in the directory, our paste applications can use them. If not, you're out of luck anyway. So, right? You don't necessarily have to participate in the paste in the Juxta file transfer network to run paste apps, right? If you want to just have your own, in a directory, you can do that too. You want to manually transfer those or have them preloaded, you can do that too. Right? We don't want to have to lock them into. You have to be able to transfer paste files if you want to participate in a paste project. Okay. One of the big things here is that opens the door to having specialized code. You know, like for particular platforms or whatever. Okay. So we have these jars in a directory. We might need to start creating a directory structure that mirrors the paste groups that are instantiated. In other words, ones that aren't discovered, but the ones that we're joined into. Because we'll have the yeah. So if our application directory, like wherever we install paste, right? So we have paste, right? Under there, we could have we'll have subdirectories for each of the groups we're in. So you'll have like the file group, the file subdirectory, and then you'll also have like the root group, right? The root network group, and then under there you'd have things like param sweep 1, param sweep 2, clustering, right? You'd have all these different directories, okay? And this would have all the jars, right? That would have a bunch of jars. This would have all our param sweep stuff. I mean, all our different applications. And then under that, what do we put in there? What do you think? What do we put in there? What do we put in there? What do we put under each of these directories? What else do we need to store files for?
Saves.
Huh?
Saves.
Saves. Yeah. Serialized objects, right? So serialized objects. Right? So we have all our serialized objects in there, serialized objects there. Sweet. And then when you go down, when you close down, when you start back up, you go through and you check. Yeah. You go through your directory, you unserialize everything, right? And by unserializing everything, you'll get all this information about like what the Juxta group ID and all that stuff. You'll have that stuff stored in that, so you can go rejoin the network. Okay. So in other words, you just rebuild this infrastructure inside Pace, and then let it run because they'll signal their way back to the state they were in. Any of those two things. Okay. So in something kind of the file management infrastructure is kind of separate. You know, it's kind of like you just ask the file manager, "Can I have this jar?" And it will say, "I have the jar on disk. Here you go. I don't have the jar on disk. I'll signal the network to get you the jar on disk. And when I get the jar on disk, I'll signal you, and you'll be ready to go." Okay, and we'll just basically advertise different jars. Okay, and be able to ask for that jar, transfer it to us, pop it in a directory. Okay? Richard, I need you to do that soon. And we really need file transfer capabilities soon. Okay? I am going to put in signaling capabilities. Network signaling capabilities. Okay?
Couldn't you just send, I don't know, couldn't you just make
It's like transferring a
signal?
file.
Yeah.
But we want it to just be direct transfer of stuff. Direct transfer of small signals is going to be easier because I can do that already. I've been passing stuff in the description of a group. I mean, that's simple enough. So what I'm going to do is just clutch together like a simple, here's a string type of thing, so that I can get some generic signals going. Okay, but we need generic file transfer in and out, preferably efficient file transfer, but we'll ask for that later. In other words, you should be able to swarm files down, and they just show up. So, along with that, included with that is maintaining the files. In other words, we need an object in the Juxta subsystem that you can just ask it, "Do you have this jar?" And it will say, "Yes, I have this jar." "No, I don't have this jar." I'll go get it, and then I'll signal it. So that's the main thing, not the actual data transfer, but this idea of, "Hey, do you have this file?" "No, I don't have this file." Or, "Yes, I have this file." But either way, you're going to get a signal back saying, "Here's the file." Right? So this stuff right here will kind of like, when you start loading into an app, you'll kind of say, "Oh, I need this file." So I'll send out a signal, "Need file." And then you don't do anything. You're asynchronous. You just wait. You just sit around dormant until you get a signal that says, "Here's the file." And then you say, wake up, and you say, "Oh, here's the file. I'm opening it. I'm parsing it. I'm bootstrapping. I'm doing all this junk. Done." Signals going in. So signals going into the file manager. Right. The file manager object is need a file named so and so. Signal that comes out should be here's your file. You don't even have to signal can't find the file because the app will just sit there doing nothing. There's nothing you can do if you can't find the file, so it might as well just sit there in the list of of things that you want to join that you can't join. Right? So we need that. We need this. You already started on that, so you do that. What am I having you do? Huh? I think I'm going to route these remote signals. Get these remote signals routing in and out of the apps. That's a good idea. You start working on serialization. Well, the serialization is still there. On where you're going to put it, get the directory structure set up, and then also, inside that you're going to need to say, okay, what will the app look like when it's state saved and when it comes back up. Concentrate on parameter suite, because we're obviously going to need a generic way of saving state within paste, but I think this directory structure is going to do that. That along with just storing some info inside the app instances, just store a little bit of info like the paste, the just the peer ID and stuff like that. Basically, we'll save some state on the group tree, that group object, that paste.group object, that tree. We'll save that state in kind of a generic kind of above all this stuff. There's a paste directory that has that group tree, but that will pretty much map directly to the directory structure. Serialization inside that will occur. So we'll kind of walk through the group tree, and every time I hit a group that doesn't have all its info, I'll just go to the directory and load whatever I need to load. So, we'll have kind of a global. Right now, I have one global signal, and that's quit. So we'll just add in like a checkpoint global signal or a save state. Let's just call it checkpoint. A checkpoint global signal, and a the loading. I think it's just going to happen in the app launcher. I don't think we need to signal it. There's nothing to signal if we're loading it. So, yeah, so it'll just load. And once it loads, it should be in a state that its signaling is ready to go. Yeah, should get some signal. Well, let's see. So you work on persistence for parameter suite. You do this config. Get file transfers going for me. I'm going to put in a little bit, track CVS to see what I'm doing with the signaling. You might be able to use that to do some of the file stuff on. Because once I get signaling done, I should be able to see two apps playing with each other. Just bootstrapping with the generic loaded stuff we have. Yeah, giddy up. Keep getting that. Code. I want to see a lot of code. And then also be reading abstracts of those papers. We are going to need stuff from that papers for doing things like swarming, file download, searching, stuff like that. Right now we're just going to track everything, but that doesn't scale, so we need to be ready with all that stuff. And you've had plenty of weeks of not doing much, so don't be surprised when I spring reading some papers and writing stuff on. So you should be reading papers. I know you guys aren't. Don't lie to me.
Yeah.
You read some? I'm very surprised by
the
it.
grape paper. Yeah, I read one.
Oh, grapes? Okay. Yeah, so I mean, let me just commit these real quick. But yeah, be reading papers. read these papers for ideas, for stuff that we can implement. Look through them and see what kind of stuff, how are they solving this kind of thing. Just commit these. Also get into the habit of using CVS, like get familiar with some of the other features, like checking on changes, the merging, the, rolling back and all that stuff. Just get comfortable with it so that we can all start working simultaneously. Right now it's been easy because most people are just working on one little thing, while they're sitting there, and then they'll check it in and be done. But, as we start getting into these bigger kind of implementations, you're going to have stuff checked out for longer, which will mean, and you're going to be touching more of the infrastructure where you're going to have to merge in. So, giddy up. All right, stop that.